So, a video for U3A6 rates of change in response to a couple questions I had about rates of change. Rates of change go hand in hand with slope, and um, in this case, where we were in the, or where we are in the course content, we're looking at table values. So, traditionally, you have what we call a Cartesian coordinates, set of coordinates, which have your x and your y value, um, and then you plot the points. And usually in a table of values like this, you have your x values going up by 1. So from 0 to 1 to 2 to 3, and then your y values go up by whatever they go up by. And if you want to look at the first differences here, what you do is you take this number here and subtract the term before it. So 19 subtracts 16 is 3. And you can also just eyeball it and say, 19, how do I go from 16 to 9? I add 3. How do I go from 19 to 22? I add 3. How do I go from 22 to 25? I add 3. First differences are the same. It's a linear relationship. And my rate of change, which is this, represented by delta. Okay, the Greek alphabet starts off with alpha, then vita. Oops, that's not ugly vita. Vita, alpha, beta, gamma, and then delta. Delta, fourth letter, looks a little bit like A, B, C, D, but this makes more of a TH sound. And we call it delta. Greeks call it delta with the TH. But delta represents change, and you look at the rate of change here for your xy coordinates and just say my first differences are 3, I'm going up by 1 each time, so my rate of change is 3. Very simple. Where it gets a little more complicated is when you look at table values for word problems, or sometimes you can even have Cartesian coordinates that have x values that do not go up by um, 1. So here, you notice here, I go from 0 to 4 to 8. I'm jumping by a regular pattern of 4, but it's not 1, so that would change how I would find my rate of change. Let me use a word problem here, and I don't know what the word problem is all about, but let's say I have a table of values which involves A and B. My A values are 60, 90, 120, and my B values are 400, 520, and 640. So if I want to find the rate of change here, I can use this formula here, which I will in a second, which is delta y over delta x. But the other thing I can do is say, what happens in this dependent value column, right? So x and y is your dependent, b in this case my dependent. I'm going from 520 to 140, or sorry, 520, from 400 to 520. So I'm going up 120. So if I was to go over here, what's my change in y? It's exactly what I just did there, 520 subtract 400, which is 120. So I'm going up by 120 each time, and this is also 120. So there's my change in B, or my change in Y, if I have my X, Y coordinates. And then I want to know, how does this column change? So this column doesn't go up by 1, it goes up by 30. Okay, 60 to 30, 90, 30, 30. And how would I show that? Well, X2 is 90. Okay, so I use a set of points, 520 and 90, or 90 to 520, and then 60 and 400. And if you went the other way around, if I said 400 subtract 520, and then if I went 60 subtract 90, I'd have the same numbers, but they'd both be negative. My answer would turn out to be positive anyway. So if I look at this, I got 120 over 30, which means that my delta y over delta x, or my rate of change, is 4. So that means for every change in A, every time I go up 1 in A, I go up 4 in B. And that makes sense because, look, I've gone up 30 from here to here. 4 times 30 is 120, which is over here. So I hope that makes sense for rates of change. That's your M in your y equals mx plus b. It's the same as your slope, and everything kind of ties in. Okay.